Welcome back, everyone. This is the last section in Chapter 15 of Oxidation and Reduction, and we're essentially looking at a backwards battery. In the last lesson, we looked at how that if you were to a separate a metal submerged in its own metal salt, and then joined together, if one metal was higher up on the activity series than another, and thus more readily oxidized, then the other metal, whatever was lower, could steal electrons from it. And so the one terminal would simply disintegrate and become part of the solution. And then in the other vessel that's connected to it, the whatever ions are in the solution would simply attach or attach itself to the piece of metal that was submerged. So you end up with a spontaneous current. So that is what the whole world is looking for: a beautiful, cheap battery that can hold lots and lots of power and transportable very easy. And so lots of things runs on battery power. So anything that's AC current often can have a DC component, and so you could put batteries in something, even very small things. Your computer could have batteries, cadmium batteries. Your iPhone could have cadmium batteries. Your um, flashlight could have magnesium or manganese batteries. And so your car would have lead batteries. And a lot of this is based on the cost. What kind of cost is it going to cost me to buy a battery? What kind of battery do I want? Do I want a battery that can last a month? Do I want a battery that will only last a couple of hours? It depends on how small it is and depending on what you're willing to pay for it. Okay, so this is backwards. This is using energy. So instead of generating energy like a battery, I'm using energy, and instead of eating away the more oxidizable metal and plating the less oxidizable metal, I'm doing it backwards. So for instance, let's say that I have silver. Silver is very, very low on the activity series. That means very few things can oxidize it. Gold could oxidize silver, platinum could oxidize silver. So if you put a piece of silver in some silver nitrate on one side and a piece of gold in some gold nitrate on the other, the silver would be eaten away and you'd have a very, very expensive battery. Extremely expensive battery. And it would still just light a light bulb, but it would be very expensive to do it. But if you were to take power, if you were to actually add electricity into this, instead of let it happen by itself, if you could drive it backwards, and instead of eating away the more oxidizable terminal, you could actually take the more expensive metal and plate it on the cheaper metal. And when people realized how to do this, they made a lot of money, because now instead of having a silver teaspoon that would cost a fortune, you could have a very cheap teaspoon, plated in a little tiny bit of silver, make it look beautiful, make it look like it's a solid piece of silver, but it's really just plated. You could take a teapot and plate it in silver, made out of zinc or something cheap, something very easy to work with, make tons of them in China, and then plate it in a couple little micrograms of silver, and the thing would look like $1,000,000. People would buy it. You could take, they used to do in the 50s, take iron that your bumper was made out of and chrome plate it, and it would look like gleaming silver. That's a real muscle car. Okay, so if you essentially take a battery and go backwards, you can get a plate, and that's what we're going to talk about today. Okay, so this is called non-spontaneous. Spontaneous happens whenever a something lower on the activity level series steals electrons from the more readily oxidized. Okay, and it produces energy. That's a battery. But if it's non-spontaneous, that means it's there's some some atoms that are not going to give away their electrons unless you really, really push them to do it. So you don't always steal the muscle guy's milk money, because that's not always a good idea. It's possible to steal it, but you have to have a lot of power to steal the strong man's milk money. And that's what you're going to do today. We're going to take a cheap metal like zinc and plate it in silver, or take silver and plate it in gold. I guess the czars used to do that because they thought that was just really, really super arrogant. They would have a silver bowl and they would gold plate their silver bowls. Okay? Think about what's going to happen to him when he's judged. All right, in any case, let's go on. If a copper strip is placed in zinc, now remember when we made a battery, copper was placed in a copper solution, zinc was placed in a zinc solution. But if we reverse that, the copper is placed in a zinc, the zinc is not going to plate the copper, okay? Because the copper is lower down on the activity series and there's nothing to steal. Okay, so the zinc can't steal it, so nothing's going to happen. This is a non-spontaneous, nothing happens reaction. Okay, if you want to drive the reaction, so if you want a zinc plate copper, then what you're going to have to do is you're going to have to put energy into it. You're going to have to add electricity rather than require electricity, or you're going to have to add electricity rather than get it. So the activity series has the most easily oxidized at the top of it, and the less oxidized at the bottom. Okay, indicates which element will react with the ion below it on the series. Okay, and so if you have something like here's zinc and copper. Okay, copper's way down here and zinc is way up here. What that means is the zinc usually can simply disintegrate and the copper can be plated. Okay, so you can oxidize the zinc and reduce the copper. But if you add energy, you can actually plate one metal with another. Okay, and so you essentially will drive away the very outside layers of the atoms and replace them with the other atom. So all the cost is on the inside that you can't see. That can be the cheap stuff. And then the outside that you can see becomes the expensive stuff. And that's called electroplating. Okay. So what happens from the activity series, oxidation of the copper is below the oxidation of the zinc, and it's not spontaneous. But if you add electricity, you can force it to happen. Okay? You can force it to happen. So an electrolytic cell uses an outside energy source, that's what the battery is, to drive a non-spontaneous reaction. For example, copper plus zinc, the zinc solution that's here, the zinc ions, can essentially plate zinc onto the copper. Okay, you can make a copper on the inside and zinc on the outside. And you may not want to do that if the outside is cheap and the inside is expensive. Like, I think that would actually be stupid because copper is more expensive than zinc. I don't know why. I guess because all the druggies are stealing the copper pipes out of your basement. But if you were to have something like silver plating zinc, that would be really beneficial. So the electrolysis is happening just like the battery, only it's happening in the other direction. So the ionized, something that's ionized is going, the oxidized, whatever's oxidized is is having electrons stolen from it. But in this case, what's being stolen from it is lower down on the activity series instead of higher up. So you can choose what you want on the outside. It doesn't have to be copper on top of copper like we saw in a battery. It could be anything on top of anything. So this is more just an informative thing. I'm not going to make you do any of the stuff to it. I just want you to kind of see how to do it. I would love to have a chrome-plated bumper on a 1950s muscle car. But in any case, I'll see you in class.